Okay, so let's build a simple circuit just to see if this is true or not. The anode is positive. So let me turn on an LED when we get a rising, let's say. 330 ohms is fine for 5 volts. Okay, so we've completed a loop here. How do we create the pulse? Maybe just, do we use a button for that? Okay, so I'm gonna push the button. Terminal 1 is gonna connect to terminal 2, and I think 3 was our interrupt number. Okay, so this pin is gonna go to 5 when we push the button. Let me just hook up power. Alright, hopefully this circuit makes sense to you. Let's put the interrupt after the handler. Let's see if this works. And the thing we want to do is, let's just set 7 to an output, and let's just run a while loop forever. I guess the Arduino already does that, right? So you can see in the setup, they set the attachInterrupt. So we'll go to setup, put the attachInterrupt here. Okay, so what do we have? pinMode 7 is now an output. The loop is gonna run. Let us set pin 7 to high. Actually, we might have to toggle. So what I like here is the state. They actually toggle the state, so we might be able to do something like that as well. We can define that as char state is equal to 0. Right, okay, so let's just do an else statement. Maybe I can walk you through the code. So you see the loop is empty, so we have nothing in the loop, but we've set an interrupt. So whenever this interrupt is rising, so whenever we push the button, we're gonna go from low to high on the yellow line. So that's gonna register by the interrupt on pin 3. It's gonna call the interrupt handler. In our interrupt handler, we have set state to be the opposite. So first it's 0, then it's going to flip it at 1. If state is 1, then we set the pin to high or else to low. Hopefully that explained it. If you don't understand, that's totally fine. Let this concept just sink in a little bit. Try doing this yourself. So let's see if this works first. Okay, so let's start the simulation. It's complaining. Okay, it doesn't have, so let's do void interrupt handler. There we go, that should probably fix it. Nope. What is it complaining on now? 25? What's it complaining about? I never closed my else bracket, is that it? Yeah, I think that might be it. Okay, yeah, I forgot to close my brackets. Okay, let's see. Push the button, nothing happens. Great, let's see. Let's actually just measure whatever the voltage is here. 0, and when I press the button, it's still 0. Well, that's odd. Oh, because it's grounded. We're gonna need a resistor. Okay, my bad. Okay, this is much better. There we go. Okay, now we have voltage. Okay, so sorry about that. I pulled them together on the ground. Okay, so let's see. Yeah, so every time we click the button, now we're toggling the LED. You see that? So if you're in real life when you're doing this, you might have some trouble with the bouncing of the button. If that's the case, you can put a capacitor here and draw that to ground as well. Maybe a 2 micro. Let's just go 1 micro. If you're having trouble with the LED flickering or not really behaving as you wanted it to, the capacitor is going to help you hold the voltage more stable. Alright, so this is pretty cool, right? Press the button. We're toggling it on and off. I introduced some logic here with the state and the not state. So this is really cool if you just want to flip from a 0 to a 1. You can do this line. Yeah, so that's one way to do a button controlled LED, and how to use the attachInterrupt.